Alright, hello everyone, so welcome back to my channel. Today I'm gonna do a problem called delete and earn. You're given an array num, you want to maximize the number of points you get by performing the following operation. You pick a number, random number, any number in here. You delete it to earn n points. So if I delete 4, I have 4. Right here, if I delete 3, right? Let's say this is 3 over 3. I will get 3 plus 3 plus 3 is gonna be 9. So I get 9 points and I delete the 3 right here. Afterward, you must delete every element equal to nums minus num i's minus 1 and every element equal to num i's plus 1. I mean that if I choose 3 right here, I must exclude the 2 right here and the 4 that is right here, right? Because 3 plus 1 is 4, 3 minus 1 is 2. So first, when you look at this problem, you will see they give you an unsorted array, right? If you do and by the way, you're trying to maximize the point. If you try to solve this in the unsorted array, it's gonna be extremely hard because you have to scan through every single element to try to delete the 2, and that's not efficient. We have to do something better, which is like this second example right here where everything is sorted. It's 10 times easier, right? So if we have 3 right here, we have 4, we have 2. Let's say we choose 3. We want to get all of these 3 number, right? Because why not, right? We just choosing 3 number right here, and then we just ignore the 2 and the 4. So what if, let's say we convert these input into a count, right? So let's say we have 2, 3, 4, and we have a count. 3 will have 3 number, 2 will have 2 number, and 4 right here have 1 number, something like this. And we have this nice chosen one. Let's say we're trying to choose 2 right here, right? We choose this point with 2. We just look up on the hash map and then we times by that count, which is right now is 2. So we get a total points of 4, right? Then we check to our left, check this value to our left and see if that value is actually 2 plus 1, right? If it's 2 plus 1, we have to skip it. So we have to jump to 4 right here. So it's going to be 4 times 1 plus the current 4, which is 8. So we have 8 right here, right? So if I choose 2, 3, 4, if I choose a 3 right here, we have to ignore a 2. So we already do that. If we choose the 3, we ignore a 2, right? And we ignore a 2. We get a 3, we multiply with the count, which is 9 right now. We check with the 4. We check if 3 plus 1 is 4, and that is absolutely right. So we will have to skip the 4 and move on to the next point. Let's say we have 3 and a 5, right? We check to the right. 3 plus 1 is not equal to 5, right? So we can easily continue this loop. So we have to recursively do that. So I will just try to code it up and see. So first of all, we have a count, right, which is a counter of num, and then we have to sort the nums, which is equal to sorters of the k for k in range, actually in count of key, right? So we have a sort array and we also have a count. Then I would just do a DFS function because this needs to be solved in recursively, right? You have to choose an item or not choosing an element. So if I is greater or equal to the length of the sortest num, make sure it's a sortest num, right? We have to return 0. And then in here, we have to perform the choose. If we choose the current one, what happened, right? So I would just say choose will be equal to the choose would be equal to the sortest, the sortest num of I times with the count of the sortest num, I, right? So this is when we are choose. But if I plus 1 smaller, we just check to see when I draw the arrows out and it's out of bounds. So this is where we check it. So if that is out of bounds, right, and the shortest sums of I plus 1 equal to the shortest num I plus 1, right? So if the current number is equal to the next number, this means that the current number plus 1 equal to the next number. This means that we have to skip it, right? So the choose plus equal to dfs I plus 2, right? In the other case, we just move on to the next one, plus dfs of I plus 1, right? So at the end, we just we also need to have the not choose. So if we don't want to choose the current one, just skip, right? I will call it skip would be equal to just regular dfs of the next one. So I plus 1. Maybe it's more points. And at the end, we just need to return the maximum of the skip and the choose, right? In here, we just need to return dfs of index 0. So I would try to run it. Oh, I found some error. Shortest num. So let's try this again. There's some error. Sort that. We're trying to find all of these numbers. There's 2. So this is the only left. Yep, it's worked, but it's gonna have the time limit access. So to solve this problem, time limit access, we just need to add a catch to that. We call it a top-down solution. So here's a catch right here. Add if I in catch, return catch of I, right? And then we use this catch of I. It's gonna be choose skip catch of I. Oh, I bet we have skip right here. We have catch of I equal to the max of itself, catch of I and skip, right? And at the end, we just return out catch I. See if it's work. Yep, now it's work, but it's really slow. We have to even more optimize it. So the problem is, if this one we're trying to find a number in the next item, right? But this is for top-down solution. For bottom-up solution, so let's do it this way. So for the regular recursive solution, let's say we have our result right here, right? Our catch right here. We send our DFS. We call it DFS again because we send our tools to go into the future, get the result that we want in the future, and then return back to our current result, right? But in the in bottom up solution, we don't do that. We just check our previous number. Let's say we also have, let's say 2, 3, and 4, right? We have our current and our previous. So for our current, right? Our current right now is, let's say 2, which is 4 right now. Should I write it like this? So our current is right here is 4, right? And our previous right now, I just say it's 0 because it's out of bounds. So this P right here is psi. Our current is right here. And let's say we move our current to 3, for example, right? We have to check if these 3 plus with the previous right now is 0. Our current is at 3 right here. The current, but it's have a 4 right here. We have to update our current eventually, right? So in here, the I at this point right now is 9 because 3 times 3 is 9. So right now, this at this index, this I right here is gonna be 9. So we take 9 plus with our previous, right? So previous right now is 0. So the at I right here is gonna be 9. And then we want to update our current, right? So we have to check if I at this point at 9 is greater than 4 or not. So 9 is greater, so we cross 4, we add 9 right here, and then we update our previous to 4, right? So let's move this. Oops, let's remove this. Right, let's remove all of this. Right, we move our P right here, right? So we move our P, go here. So at this point, it just means that, at this point, the biggest number at a previous pointer is gonna be 4, right? It's gonna be 4. This one, C, is gonna be 9, right? So that is what we do with our bottom-up solution. It's gonna be more clear in the code. So I'm just gonna code it up, and it's gonna look really similar to this. So 4, let's say I have this, right? I have my previous, I just set it up. This is the current of 0, and the shortest sums I times the count of exactly that number, right? Just like that. Previous, and then let's say for I in range of 1 length, wait, what? Of 1 to length of the shortest sums, right? We have our temp equal to the current, so we just have our current in the temp variable. Then we want to update our current, so if same thing down here, right? But we have to change it because we check the previous value, right? So check the previous value. If it is the previous value, we just want to let's say we have a current point, right, which is gonna be equal to the shortest sums of I times the count of the current of the shortest point, right? So that is our current point. So we have to check the max of the current with previous plus the current point, right? Current, check that, and we only want to include our previous only when this one is equal, right? And in the other case, only when let's say you are at 3, previous is 2, right? If that happen, we want to skip the current one. But if that not happen, we want to include the current one, right? So it's just gonna be the current point. It's just gonna plus current point, right? And then we have to update our previous equal to temp, and then at the end we just need to return the maximum of the previous and the current. Let's try to run it, see if it does work. And again, very slow. What the hell? Let's try again. Yep. But this is clear. It's gonna be faster in both space and time complexity. So this one is gonna be of n time complexity, and the space is gonna just it's actually, since we sort, it's gonna be O of n log n space complexity, and because we have a count, I would say the space also O of n time complexity. So hope you like the solution, and I'm gonna see you soon on the next video.